All right, we are going to be looking at some symmetry, which is basically identifying whether functions are even or odd or neither, and what that means about the graph and about the table and about what you can do algebraically. Okay, so first of all, we're going to be looking at even functions. Even functions are symmetric about the y-axis. So that means you can fold a graph in half over the y-axis and both halves will be exactly the same. But it has to be folded in half literally along this line right here. If it cannot be folded in half exactly on that line, it is not an even function. If you look at the table, I want you to notice that when x is 3 and x is negative 3, your y values are the same. When x is positive 2 and negative 2, your y values are the same. So that's where you get this, that when you plug in one number and you plug in its opposite number, so positive 2 and negative 2, you get the same answer for your y values. That's what that means. That indicates that you have an even function. Okay, then they're also symmetric. This should say x-axis. This is a graph that is symmetric to the x-axis. Okay, and graphically that means you can fold it right across the x-axis and it is symmetric there. So I have to be able to fold it exactly on this line. Not that it can be folded in line in half horizontally. So in other words, if the function were right here, yes, I could fold it in half horizontally and it would be perfect. However, I didn't fold it along this line. It has to be folded along the x-axis. Basically, here your y's are opposites of each other. Okay, so when I plug in 9, I can either get 3 or negative 3. Okay, I have two options. This is actually not a function because it does not pass the vertical line test. And then there's odd functions. So really we kind of worry about whether something is even, odd, or neither. This last one will be neither, but it does have a unique property to it in that your 1x value can have either a positive or negative y value. Okay, and then there's odd. And that means that it is symmetric with respect to the origin. Basically, that means that you have to flip it over the x and then the y. So if I think about this little section right here, and I flip it over the x-axis, or I'm sorry, over the y-axis, I would be here, and then I flip it again over the x-axis, I would generate this half. I just flipped it over the y and then the x, which basically means it's symmetric about the origin. Okay, so if you can flip it over the y, then the x and the two halves match up, that's what being an odd function means. Okay, that means when you plug in a number and it's opposite for x values, you get opposite y values. Notice when I plug in 3, I got positive 27. When I plugged in negative 3, I got negative 27. That indicates that they are opposites. So this is telling me when I plug in one number and it's opposite, I get opposite answers. One's positive, one's negative. Okay. So we are going to look at these. We're going to check algebraically whether they are even, odd, or neither, and then we can certainly take a peek at the graph too and confirm it that way. But the first thing I'm going to do is I'm going to just confirm it algebraically. And we can look at the tables too and help us decide that, okay? So algebraically, I'm going to just pick a number and I'm going to pick its opposite. I would not pick 1 because 1 has some weird properties to it, so I would try to pick a number other than 1. And you can pick any number, and you can pick 1, but sometimes 1 will trick you. I'm going to pick 2. When I plug in 2, then f of x is 2 squared plus 3, or f of 2, I should say, is 7. Okay, so if you think about this, I get 2, 7. I plugged in 2, I got 7 for the output. Now let's see what happens when I plug in negative 2. When I plug in negative 2, f of negative 2 would be negative 2 squared plus 3, which is again 4 plus 3, which is again 7. Okay, so when you plug in an answer or plug in a number and it's opposite and you get the same y value out, that's like this. When you plug in a number and it's opposite and you get the same y value out, that means that you have an even function. So this right here is even. Okay. That means that if I were to graph it, I should be able to fold it right along the y-axis, and it would fold perfectly in half. And I don't have this graph up here, but if I were to graph it, it would look something like this on my graphing calculator. And obviously I can fold that exactly in half on the y-axis. And you can graph it on yours and confirm it if you would like. Okay? Then here's another one, tell whether it's even, odd, or neither. Again, I'm going to pick a number to plug in. I'm going to plug in 2. When x is 2, then f of 2 would be 2 squared, which is 4, plus 2 cubed, which is 8, and I get 12. If I plug in negative 2, f of negative 2, I have negative 2 squared, which is 4, and negative 2 cubed, which is negative 8, and I get negative 4. So I plugged in a number and its opposite, and I got completely unrelated y values. This one is neither even or odd, and we'll look at the graph in a minute, which means I can't fold it across the y-axis, and I can't fold it across the y and then the x-axis to get it even, to get it symmetric, and so that's how it works. If you had plugged in 2 and negative 2, this answer came to be 12, this answer came to be negative 12, then you would have an odd function, okay? But this one is neither even or odd, which means I can't fold it across the y and I can't fold it across the y and the x. Okay, here's a table, and we're going to look at whether these are even or odd here in just a minute. And so I want to look at what happens when I plug in a number and its opposite. A number and its opposite generates completely unrelated y values. So this is neither. When I look at a number and its opposite, I get the same y value. So this is even. When I look at a number and its opposite, I get opposite y values. So this one is odd. All right, then it says use the given function to draw the other half of the function if the function is even, okay? So if it's even, you are going to be able to fold that across the y-axis. So you can kind of sketch this if you want, or you can think about coordinates. To sketch it, you can just think about how it's going to be symmetric, and it should go something like that, okay? If you want to be more exact, pick some kind of key points to this, okay? So for instance, this point right here, I would say has the coordinate 3 and 3.5. Well, its opposite should be negative 3 and 3.5. So it should have a high point right about here, okay? This point, let's say, is 6, 0. Its opposite should be negative 6, 0. So I can kind of graph, and that will help you sketch this just a little bit more accurately, but it should look something like that if it's even, okay? If it's odd, it has to get flipped over the y-axis and then the x-axis, okay? So first of all, if I flip it over the y, it's going to look something like that. And then I have to take that and flip it over the x. Okay, and when I flip that over the x, it's going to look something like this. Okay, and this is the part that I care about. I don't need that red dotted line in there. I'm just telling you, you have to flip it over the y and then the x, and this would be the other half of it right here. Okay, so I can tell that this is an odd function. All right, then we want to just kind of take a peek some more at what happens on your graphs. Sometimes that can trick you. This is asking me, is there a point of discontinuity at x equals 0? And I should be able to tell, you have to think about this algebraically. Discontinuity means the graph doesn't exist for some reason at x equals 0. Either there's an asymptote or there's a hole or something. Well, clearly there's something because I can't have 0 in the denominator. Okay, so now I'm going to graph this and I'm going to look at somehow how your graph can really look deceiving. Okay, the colored, if you have the colored graphing calculators, they're not quite as deceiving as the black and white ones, but even the colored ones can be kind of deceiving to the eye. So we want to make sure that we get this cleared up and have you point out some things on your calculator. All right, so the function was x cubed plus x divided by x. All right, x cubed plus x divided by x. All right, I'm going to go ahead and hit graph. Clearly, I know that it's undefined at 0. It has to be, and I don't know if you can tell it, but if you're not zoomed in very far, then you probably can't see that there's a hole right there. So one of the things you can do is to use your table, okay, and look at when your x value is 0, if that's kind of your point in question, and in this case it is. Look at when your x value is 0, if my calculator ever catches up to me here. There we go. And you can see that you have an error at 0. All right. So clearly I have a point of discontinuity at x equals 0. The other thing that you can do is go back to your graph and you can zoom in on this. Okay. So I am going, ooh, I wonder what's happening at 0. Maybe I want to change my window and I want to go from like -2 up to 2 and just go up by, oops, by 0.25s. And maybe let's do the same thing on our y values. Okay, and then we should be zoomed in on that graph. And that didn't work so very well, did it? Kind of did. If you're zoomed in on this graph, sometimes it's a little easier to tell if you have a hole there, but maybe not always from the graph. Sometimes the tables are the right place to look, okay? And it's going to be tricky sometimes to see those holes. So you have to think about things algebraically as well as your graphing calculator. Do not rely 100% on your graphing calculator or you are going to be deceived, okay? And let's look at a couple of other situations that sometimes happen. This is asking you, are there any x-intercepts for the function? Remember, an x-intercept is where it crosses the x-axis. So I am going to stick this one in and decide whether I think it crosses the x-axis or not. Okay, so 3 minus 1 over, I have to try to remember this function now. 3 minus 1 divided by the square root, not 11, this thing gets a little snap happy sometimes. 1 divided by the square root of x squared plus 1, is that what it was? Minus 1. All right. Close that and graph. So my question is, does it cross the x-axis? 3 minus 1 over the square root of x squared minus 1. All right. So my question is, does it cross the x-axis? Well, again, it certainly does not look like it, okay? But let's kind of peek at this and see. And let's see if our tables can help us at all. All right, so first of all, I'm going to go to my graph. And if it crosses the x-axis, it's going to be somewhere right around -1 and somewhere right around 1, if it crosses at all, okay? So my graph, I can zoom in on it if I want to, or I'm going to go to my table, okay? And actually, I'm going to go to table set. I am going to start my table at 1 because that's one of the points in question. And then instead of going up by 1, I'm going to go up by 0.001. And now I'm going to go back to my table. And I'm just going to see, does it look like it ever crosses the x-axis at 1? Okay, and I don't think so because all of these are errors down here. Okay, so it certainly doesn't look like it's crossing the x-axis at all. Okay, my numbers are not getting, they're not moving to a positive number, are they? Okay, so you really want to think about that. They're getting bigger and bigger and bigger and bigger, but they're really not moving to a positive number yet, but maybe they will. Let's see, we're going to keep going and keep going and keep going. I'm getting closer and closer and closer to 0. Let's see if I ever cross 0. Might take me a while. Oh, I'm getting closer. Oh. Okay, now I wish I could stop this baby, but I can't. Clearly, I crossed from a negative number to a positive number down there. Okay, so I'm going to scroll back up here a few and see what happens here. This thing just kind of goes crazy on me. All right. Clearly right here, okay, I crossed from a negative y value to a positive y value. Okay, I crossed from a negative y value to a positive y value. So somewhere in between 1.054 and 1.055, I have an x-intercept. I might call it 1.0545, which is halfway between. But somewhere between there, I do have an x-intercept. And if I looked at the graph or looked at the table for the other side, which would be at -1, the same kind of thing would happen. Okay, so I do have an x-intercept, even though it doesn't look like it when you first look at the graph and when you first look at the table. Okay, so just know that that's what's happening. All right. So that sometimes happens on your graph. And then let's look at a third situation here. Okay, this one says solve the equation graphically just by being able to adjust your window. Okay, so we are going to put this equation into our calculators and adjust our window so that it fits. And the tricky part to this is to getting your window adjusted to the right spot. Okay, now potentially I could have 3 solutions to this graph because it's an x cubed equation. Which means it potentially could cross the x-axis in 3 spots or have 3 roots or 3 solutions or 3 zeros, whatever you want to call it. All of those things could happen. So let's go back here and let's change our window. Well, let's put the equation in first. All right, so we have x cubed minus 1.1 x squared minus 65.4x plus 229.5. Okay, I can't remember if my window's off right now. I'm just going to start in my normal window, which is Zoom 6. All right, and clearly this is not going to happen. Okay, so I am not hitting that graph at all. Okay, it looks like I only have 2 spots where my graph crosses my x-axis. It looks like I have 1 spot right here. Okay, that's certainly what it looks like to me. And I can figure out that spot by doing second trace and number 2. And then go ahead and moving my cursor. And it looks like it's at about -9-ish. So I'm going to move this until my x value is about -9. So if you follow down here on your x values, some people go, I can't find my cursor, I'm lost. Well, you aren't going to be able to see it until your x values are close to -9, because that's where it looks like it about is. And I'm not there yet. I should be able to see it. Why am I not seeing it yet? Huh. I don't know where my cursor is. Not seeing it, am I? Okay. Did I lose it? Second trace. Number 2. Where is my cursor? Oh, really weird. It's not helping me at all, is it? All right. Let's change our windows, okay? We want to, let's try to zoom in on this part right here, because I can see that that's what's happening there. So we're going to zoom in on that part, okay? So we're going to change, I don't need to probably change my Y values, but I'm going to change my window. And I am going to change my X values. I don't know why that happened with my X values. I'm going to change my X values from negative 10 to negative 8. And I'm just going to show you this. Okay, again, what the spot that I want to find is this spot right here. Okay, so we will go second trace, number 2. All right, and my cursor you can see is right there. So I'm going to hit left bound, enter, right bound, enter, right on it, maybe, enter. Okay, so it does happen to be at exactly negative 9, 0. So one solution is negative 9, 0. Okay, now I'm going to go back to my Zoom 6. Okay, and I can see that I have another spot, if my calculator ever finishes making it. I have another spot where that crosses, at least one spot. This is taking a really long time. Am I frozen? Let's try this again. Hang on, sorry guys, there we go. Okay, it looks like I maybe have a double root right here, and it looks like it only crosses the x-axis in one spot. So we're going to zoom in on that area over there and see what's really happening as we zoom a little closer. It looks like it's about when my x value is about 5. So I'm going to zoom in on that little region right there. So I'm going to go and, oops, I'm going to set my window, sorry. And let's go from when x is 4 to when x is 6, let's say. And then we don't need to see all those y values either. Let's just go from when y is negative 1 to y is positive 1. Okay, and let's just do that and see what happens there. And you can see that it actually barely dips below the y-axis and that there's actually 2 roots there. Okay, so you need to do second trace, number 2. I'll go a little left of that point, hit enter, a little right, hit enter, and right on it, hit enter. And one of them would be where x is 5, okay? And then, so my solutions are x is negative 9, x is 5, and then I have one more spot right here. So you really need to zoom in on those spots and figure them out. So second trace, number 2, again, I'll go a little left, hit enter, a little right, hit enter, right on it, hit enter, and my last spot would be when x is 5.1. Okay, so although it looked on the graph like there was only 2 solutions, 2 places across the x-axis, there was actually 3. Okay, so you have to be really, really careful when you're using your graphing calculators and thinking about things algebraically as well as graphically. Okay?